Okay, now we are slowly moving our object closer to the lens. And so up here at the first sentence it says, when the object is placed at the focal point of this convex lens, you will not get any image seen because all rays that are going through the lens will come out parallel. Okay, and so now the next scenario is, let's move inside the focal point and see what happens. And when we do that, we're going to get a virtual image, which means it can't be projected onto a screen, and it's going to be upright, and it's going to be larger. And this is what happens when you use a magnifying glass. Your object is your fingerprint or whatever it is that you're looking at and you want to make larger. You're moving that lens close enough to it so that instead of being upside down and smaller, it now flips to upright and larger. So let's look at how this drawing is done. Okay, so here's our ray diagram. If I make this a little bit larger so we can see it here. Okay, ray 1 is just like it was in our last scenario. It goes parallel, hits the lens, and then it bends through the focal point and extends out. Ray 2 is the one that is slightly different. Instead of going through the focal point like we showed in the last section, this is going to come from an angle from the focal point, go up, hit our lens, and then goes out parallel. As you can see, these two are never going to cross, and so we extend sight lines backwards from that ray 2 and from this ray 1, and where they cross, that is where our image will be seen. And as you can see based on this drawing, it is virtual because it's on the same side as the object. It is also upright, and it is larger. Okay? Now, as we look at this, here is this again. If we were to do a problem, we would still use the thin lens equation. And let's say this was 10, and this, for just simplicity's sake, for the math, we'll say it's 5, even though it's not quite drawn to scale. Okay, so we're going to say it's 1 over 10 equals 1 over di plus 1 over do. If you do the math, what we would get is 1/10 minus 1/5, which can be written as 2/10. And what we'll see here is we get 1 over di equals negative 1/10, and therefore di would equal negative 10. Now, obviously I didn't draw this correctly. It should have been much closer to it, as you can see on there. So what does that tell us? Well, when we have a convex lens and we're inside of the focal point, our image will be negative. Okay, you'll have some practice problems later on to work on this. Just make sure you remember that. If they give you the image distance using a magnifying glass, you got to make sure that you make it as a negative number. The next thing we'll be looking at is the concave lens.